Unit 5, Day 6, solving log equations. Friday we solved exponent equations. Today we're going to solve log equations. And you might remember that on exponent equations there were two types. Ones that was kind of easy if you had e to something equals e to something, like the somethings were equal to each other. But again, there's two types. And it's a very similar situation. One type is if you have log equals log base b of f of x equals log base b of g of x, what do you think we can conclude? Yeah, let's not say we're going to cross out the logs, but we can definitely say f of x equals g of x and kind of go from there depending on what else is going on. That's our favorite type because it's a log equation, but not really. The first step is get rid of the logs and then it's not a log equation anymore. Type 2 is, I don't know how to say this other than not type 1. So you don't have log equals log. You would have log equals something else. Could be any number of things, but log equals log, simple, easy, we like that. If it's not that, then we got to do some work. For all log equations, you must check your answers. Not because it's good practice, although it is, not because you want to make 100 on your test, you do, but because you can do all the math right and end up with an answer that doesn't really work. You've had this before in other situations. They're called extraneous solutions, is the fancy math word for it. But the deal is, or what you're looking for is, you can't log 0 or negative. Like the argument, if you've got the log of a has to be greater than 0. Can't be equal to 0, can't be negative, it's got to be positive. And so sometimes you can do all the work in a problem, do it all correct, and you get down to an answer and you learn that a equals negative 2, and you're like, whoops, I can't take the log of negative 2, so I have to throw out that answer. We'll see some that where that happens. But you got to remember to check for it, otherwise you're just going to box up negative 2 and be wrong. And if you mark out all of them, then there'd be no solutions. But there could be some where one answer works and one doesn't work. So be careful about saying when that happens it's no solution. Like, maybe, maybe not. All right, a couple of type 1 equations. These are our favorite. We'll only do 2 of these because these are great. They're easy. Log base 5 of x squared equals log base 5 of 3x plus 4. Again, it's like, well, I guess that means x squared has to equal 3x plus 4. Forget about the logs. The logs are on both sides, sort of in the same spot, doing the same thing. Well, then the arguments have to be equal to each other. Oh, look, we threw in a factoring problem. X minus 4 and x plus 1. So x equals 4 and x equals negative 1. Are we okay with x equals 4? Yeah, so it doesn't matter if the answer is positive or negative. It matters what we're taking the log of, though, so be careful. 4 squared, 16. We're good with that. 12 plus 4, 16. Yeah, we're good with x equals 4. What about x equals negative 1?
Yeah.
Plug it in and see what happens. If I square negative 1, I'm good there. 3 times negative 1 plus 4?
That'd be 1.
That'd be 1.
So it could be.
So we're good on that side. We're good on this side, so both of them work. So I like that example. It shows that you can get two answers that work. It also shows that just because you get a negative answer doesn't mean that you automatically throw it out. You have to check and see what exactly you're taking the log of. Let's do one more of that type problem. Natural log of x cubed equals natural log of x squared plus 2x. Again, log equals log, our favorite type, because the first step is get rid of the logs and it's not even a log equation anymore. Don't know that necessarily makes it easy, but at least it's not a log equation. So let's move everything over. What should I do to factor that? Good, take out an x. And then what do I do with what's left? Factor that. X minus 2 and x plus 1. So I've got 3 potential answers.
0.
Because the x out front leads to an x equals 0 as an answer, or a potential answer anyway.
Oh, you gotta check it.
Got to check it. So does x equals 0 work?
Wait.
No, because the natural log of 0, that doesn't work. You have to have a positive argument. So we'll throw out 0. How about 2?
Yes.
Let's see, natural log of 2 cubed. I don't really even care what it is. It's positive, so we're fine. On the other side, we get 2 squared plus 2 times 2. All of that's positive, so we're good there. So we like 2. How about negative 1? What do we get when we cube negative 1? Negative 1, that doesn't work. So we have to throw out negative 1. It doesn't even matter what the other side is. I don't think it would work either, but as soon as one of the logs doesn't work, then you can't use that solution. So this one looked like it would have 3. We threw 2 of them out, so we're left with 1. Because you can't take the log of 0. You have to take the log of a positive number.
So if it's an x equals 0, you may as well just cross it out.
Not necessarily, because if your original equation was log of x plus 4 equals log of 2x minus, 2x plus 8, 0 would work. Negative 1 would work. Negative 2 would work. So you can't make the decision based on what x is. You make the decision based on what you're taking the log of. So you can't just look at your answer and say, oh, that one will work, that one won't. You've got to go plug it back in and see what will work and what won't. All right, those are the easy ones. We like those because, just again, they become not log equations at the first step. Let's see how to phrase this. Type 2, log equals not a log, just a number. For these, we're going to fish hook them to make them not log equations. We'll fish hook them into exponent equations. I'll show you what I mean. Natural log of x equals negative 1/4. Okay, definitely not a type 1 equation where you can just cancel the logs.
Bring e down the lower part and just fish hook it.
Fish hook it. So yes, there's an imaginary e down there, or not imaginary. That's a math word, so I shouldn't say that. An invisible e down there. And when we fish hook it, we get e to the negative 1/4 equals x. Oh, and then we're done because we just solved for x. We set out to fish hook it, and we sort of accidentally solved the problem to begin with. Are we okay with that as an answer? Like, is that the log of a positive number, e to the negative 1/4? E's positive. Negative just would flip it over. So, yeah, I don't really know what that is, but it's not negative.
So we don't.
So we're good with that as an answer.
So would an answer choice ever be 1 over e to the 1/4, or would it just be e to the negative?
So that's a really good question, especially if you're thinking ahead to multiple choice test. Like, which one's it going to be? We're probably going to get rid of negative exponents and make it look like this.
So we should just solve it out to
So you should probably get rid of the negative exponents. Now, hopefully, if you got to here, and then you started looking at your answer choices and saw that, hopefully that would trigger in your brain, oh yeah, negative exponent flips it over, there's my answer. Hopefully. Log base 3 of x equals 7.
That's 3 to the 7 equals x.
3 to the 7 equals x. Whoops, 3 to the 7 equals x.
Do we have to solve that?
So I'm going to say no. If it was a multiple choice test, I mean, your answer choices would be,
I mean, if we had a calculator,
your answer choices would probably all be powers of 3. I don't know what the next one is. We'll do it that way. So if those were your answer choices, it's like, well, that's 3 cubed.
Definitely the largest
Yeah,
number.
definitely.
That's 3 to the 4th. That's 3 to the 5th.
I'm just going to go ahead and take a wild guess.
So I guess it's that one because it's certainly not any of the others. And if you really needed to, you could multiply it all out.
Yeah, we got it up. You can just make 3 times 7.
Don't say that.
Wait. That just happened to be his thing.
You should have that as an answer choice then.
21 as an answer choice.
Will would pick it.
Just for
No, I refers that. He's already picked it.
as a joke, and you'd actually get it wrong.
You got a good grade.
Natural log of
It's not good.
e cubed equals x squared minus 8. I kind of like this one. This one.
So does that
Hold
mean
on,
there's
I have to
still
write it
invisible
first.
e?
Yeah, there should be.
Wait,
right?
no.
So there's kind of a long way around this problem, and there's a way to think about this problem and realize, wait a minute, this is easier than it looks.
ln
ln of e equals 1, but there's a 3 there.
Who cares about it?
Well, I care about the 3.
I don't. Oh,
Is there a place I could put the 3 that would be more convenient?
it's 3 ln e equals x squared minus 8 using your thinking.
And what's the natural log of e?
Ln and e you have to cancel out either way. So it's, wait, what? No, I'm right.
Yeah, natural log of e is 1. They cancel out. So x squared equals 11.
X squared equals 11.
So x equals plus or minus square root of 11. Are we okay with
Yes.
Yeah.
both of those?
Yep.
Yeah, because they're not even in the log that we're taking a log of. So this is, is this really even a log equation? I mean, kind of, but kind of not.
Okay.
you just have a test like this?
Yep, just like that, that's it.
Well, I mean, there will be those, but they're going to be intermixed with others. So it's like, well, can you figure out what to do with these scrambled up equations? Log base 2 of x plus 4 equals 5. Question?
Easy.
Can't it not be a negative? Or is that just like
So you can't take the log of a negative. But when I plug this back in, I'm not taking the log of anything with x. The only x is over here. So the negative is okay. So you're right to be worried about negative, but because of where it is in the problem, it's fine for this problem. All right, some of you guys are jumping ahead on this one, which is fine.
X equals 12.
2 to the 5th equals x plus 4. 2 to the 5th. Hopefully you're getting to the point where you have it, maybe not memorized, but you can get there quickly.
With my fingers.
2 cubed is 8. Another 2 would be 16. Another 2 would be 32.
This is why. 32. I knew I'd beat that.
So x equals 28. Check it. Log base 2 of 32. Yeah, that's fine. I'm just trying to make sure I'm not logging 0 or a negative number.
Then why don't we check the x equals plus or minus 11?
Because we weren't logging any variable. The variable wasn't even in the log on that one. Natural log of x to the 5th
5
equals 15.
x equals 15. Wait, because it's not in parentheses, you can't move it.
We can move the 5 down.
If there was parentheses, you couldn't,
Well, I don't,
right?
like if parentheses are there, we still could.
Including the 5.
If the parentheses included the natural log, we wouldn't be able to move it down.
Like for, if it was just the x to the 5th in parentheses, would that affect anything?
Nope.
So you could still move the 5 down?
Yep.
No, okay.
What do you want to do next after we move the 5 down?
Put it,
Thus divide by 5. Right, take care of the easy stuff.
then you can get rid of that stuff by fishhook.
We can fishhook with the invisible e. E cubed equals x. Plug that back in. I don't know what e cubed is, but it's positive. And then if I fifth it, it's still positive. So I don't really know what e cubed is, but I know that it works. Haven.
Why isn't it ln on the other side like whenever you move the side in front? You know what I'm saying?
I mean, the problem started like this, so there wasn't a natural log on the other side. So it started with a natural log there, so all I had to do was move the 5 down front. Like yesterday we put natural logs on both sides and then moved something down, but this one started like that. So it started with a natural log on one side only. Same thing with 6 and 5.
Can you give us?
Looking for one that something doesn't work?
Yeah.
Because everything's working right now?
You're not gonna give us a perfect thing on the test. Yes.
It's like you're reading my notes.
Yep.
Take back what I said.
Ah.
I didn't take back what I said.
I just did that for
This is gonna be so much fun.
Is that a two? Yeah.
Log base 2 of x plus 2.
This one's
Sorry, zoomed out too far there. Plus log base 2 of
This
x
is the only ones I know.
equals 3.
I wanna hear.
Well, be careful. What are you going to do
You
first?
gotta move that log over.
True.
Log
I-
2,
I can't.
negative log 2.
I don't want to move a log over. I don't want to do that.
The plus means it's
Nobody.
I would like to condense that into one log so that I can do the fish hook.
wouldn't it be
I can't fish hook now because it's like, well, who am I fish hooking off of? Which two? So let's condense them into one.
Never mind, I scratched what I said. I didn't do it right.
How do I combine?
You just,
If we're adding logs, we will multiply their arguments. So x plus 2 times x equals 3.
I wonder if it was a different log base.
Oh, great question, and someone always asks that. Like, if these were different log bases, or different bases, you couldn't condense them, which means you'd be stuck.
Do you have
So yes, that would be a more difficult problem, but far more difficult than we want to worry about.
Okay, so we're never going to worry about that.
Correct.
So
Okay,
we have to
at least
solve
not for
out the x plus 2 to times x. Or can we just leave it as those two?
What do you mean? We're not done yet.
X squared plus 2x.
So at some point we need to multiply those. Some people are going to multiply it now. Other people are going to fishhook and then multiply. Some people will be daring and do both in one step.
2, 3 equals x.
I'm not feeling particularly daring today, so
Oh, you can't.
2 cubed
I gotta keep solving it.
equals x squared plus 2x. I changed my mind. I am feeling a little daring. I'm going to change that to an 8 and move it over all in one step.
Equals what?
Mind blown, right? 2 algebra steps in one.
Yeah.
That's crazy talk.
Where'd you?
Oh, now we gotta factor
I thought it was invisible.
There's a 2 there, so it wasn't an invisible e, it was a visible 2.
4, 2, negative 2 plus 1.
So
X is equals negative 4.
4
X
and
naught
2
plus 2.
plus 4 minus 2.
X equals 2.
And the danger here is to stop and say, what was a terrible problem, we finished it, we're good. But I gotta check. So if I plug in negative 4, I get log of negative 2 and the log of negative 4. He's out.
Wait.
If I plug in 2, that's fine. Log of 4, log of 2, we're good. Olivia.
If both of our answers don't work, then no.
Right. If both answers, or if neither answer works, if you mark them both out, then no solutions. Oh my goodness, there's so many iterations of these problems. I'm trying to condense. Natural log of the square root of x plus 2 plus 4 equals 8.
Can't say that. Whoa.
Eh. Let's just move the 4 over.
Well, you're gonna say
Fix the 4.
Whoa.
I pay partial interest to.
What next?
You can make you can do the fishhook thing by adding the
E to the 4.
You know what? I could fishhook. I don't want to fishhook yet.
You can make it 1/2 and then pull it forward.
Yeah, I'm gonna do 1/2 natural log x plus 2
Wait.
Because of the square root.
because the square root's the same thing as the power of a half. Now, if you fishhooked it, you would still end up at the same answer. It would just be a little bit harder to get there.
Why would you put the half on the right?
I'm going to multiply both sides by 2 and get to 8. Now I'm going to fishhook. E to the 8 equals x plus 2. So x equals e to the 8 minus 2. Check that. I have no idea what e to the 8 minus 2 is, but if I square root it, it's positive, so I'm fine. Right, e to the 8th is really big. All I'm worried about is zeros and negatives. So I'm fine with e to the 8th. I think we can get by with one more example. Yes, thank you.
Where'd you get 8 from?
Right here, I multiply both sides by 2 to get rid of that 1/2.
Oh.
Let's do one more. I think trying to condense examples here so we're not doing 100 example problems. But we'll put a bunch of stuff in this one. So, yes, it's only one problem. Yes, it covers everything.
Great. Oh, so
Wait,
first you
it's a
divide,
plus and a
first you
minus log.
condense,
You
right?
can just get rid of it. It's a plus and a minus log. You can
When you condense first.
divide
I do want to condense,
when you divide the two.
but I can't
Oh, because of the 2 log.
I can't condense yet because of the 2.
So you can.
So is there a place I could put the 2?
Oh yeah. That's it.
I could move it back to the top. It's not usually what I like to do, but if I want to condense, it's kind of my only option here. What do I get when I square 2x?
2x squared.
Ah, I knew someone was going to say that.
No.
That's why I ask. When I square 2x,
Parentheses 2x squared.
parentheses 2x squared,
And leave it at that.
I'm going to have to fix it eventually.
Leave it at that.
So when I square the 2 and the x,
4x squared.
4x squared.
Oh, look, we all know you said 2x squared, my friend.
Let me say anything.
In your brain.
I can't say it.
Now, Jason already said condense. How am I going to condense?
Good, the dividing. So you'd put log 2 or log base 2 for x squared over log base 2 3.
Wait, only one log base 2. That's the point of condensing.
You're right.
4x squared over 3x minus 1.
Wow, this looks like old stuff.
Yes, it is old stuff. It's almost like math continues to use what we learned.
I know, right?
So
It's like we put this stuff in order for a reason.
So it'd be called history.
Math is just the history of numbers.
So if we don't want history to repeat itself, then maybe we should
Just
calculate.
stop it.
What should we do next on this one?
Tyler, what is it for doing
What do you want to do next on this one?
I would really put 2 minus 1 to
Fish hook. Oh my goodness, I gotta stop messing around and go faster. So 2 to the first equals 4x squared over 3x minus 1. Multiply both sides by 3x minus 1 because we don't like the fraction. So 6x minus 2 equals 4x squared. This looks ugly, but at least the 2 divides out.
X plus 2 equals 0.
And that will factor.
Oh, you pulled out the 0.
Sorry, I'm having to go fast here, but this is all algebra stuff now. Both of those work. Lots of algebra, lots of factoring. Try worksheet 6. Try. Do or do not. There is no try.